So previously we have seen how the attachment of electron donating groups can lead to the stabilization of a carbocation. And if I attach an electron donating group to the carbocation, the electron deficiency that it had previously was removed. So if electron donating group is attached, it stabilizes the carbocation. Now here I have in front of me an example where I have four: the first one, the second one, and the third, and the fourth. So four species I have in front of me, and now I have to tell which one is the most stable. So order of stability is what we have to find here. The order of stability. See, what we discussed previously was that electron donating group, when attached, it removes the electron deficiency, or it satisfies the electronic hunger of the positive charge. So in the first one, here, this example, you can see that I have no group attached, no extra group attached in this one. So I cannot get electrons from anywhere. So there is no electron supply to this. But when I move on to the second one, what I see is that there is one CH3 group here which can give me electrons. So this CH3 group here, what it does is, this CH3 group here, what it is going to do is, it is going to donate its electron density towards the positively charged carbocation. Similarly, moving on to the third one, I see that there are two CH3 groups now. And CH3 groups we have previously discussed in inductive effect that they have a plus I effect, or they give their electron density away from themselves. So they are the electron donating groups, as they show plus I effect. So CH3 here it gives, and these two gives electron density towards the middle carbon. So these two, this one, and in the third one I can see that there are three CH3 group attached to the center carbon, center positively charged carbon. And what happens is, now I get electron donation from three sides. Okay, now when I get electron donation from three sides, what we have previously done is, the more electron donating group present, so the more the groups of electron which can donate electrons present, more is the stability. So what happens is that when I attached more number of groups which are acting as an electron donating species, what they do is they lead to the stabilization of a higher degree of the carbocation. So if I see the second one here, I can see that there is one electron donating group, one electron donating group here. Now moving on to the next one, I can see that there are two electron donating groups here. And when I move on to the third one, I can see that there are three electron donating groups here. So if I have to write the order of stability, so the stability order, which is directly related to the number of electron donating groups present, it will be that the fourth one will have the highest stability because it is being supplied electron density by three electron donating groups. Electron density is being supplied by three electron donating groups. So 4 is greater than third, is greater than the second one, is greater than the first one. So this is our order that we wanted, of order of stability. 4 is greater than 3 is greater than 1. And if I mark it in the figure that is provided to us, so fourth is the most stable, then comes the third one, and I can put the arrows in this direction. So the more the number of electron donating group present, more is the stability. If I want to give you a generalized, if I want to generalize this, if I want to generalize this example, and if you want to remember this for the exam, for solving any questions, you can say very clearly that the 3-degree carbocation is more stable than the 2-degree carbocation, which is more stable than the 1-degree carbocation. Now, which is the 3-degree carbocation here? It is this one. This is 3-degree because it is being given electrons by 3CH3. So this is 3-degree carbocation. And we have here is the 2-degree carbocation. And we have here is the 1-degree carbocation. So I can see clearly that if I want to generalize the given example that we have just solved, I can say that the order of stability is from 3-degree and it goes on decreasing. So the more the number of electron donating groups, the more is the stability. Now, moving on, there is one other example that we are going to cover, which is in front of us. Now, in this example, you can see that one particular species is non-planar. Which one is it? Now, if you can see, and this species here, this species here is planar because the carbon attached to the other 3 carbon or the other 3 methyl groups will be in the same plane. This is of course a methane which has lost NH minus. So this is a carbocation and this will of course be planar. But if you go on and see the third one, the third example that we have here a bridge between, we have a cyclohexane and then we have a bridge inside it, and this bridge is in a different plane than the cyclohexane present. So this bridge is in a different plane than this. Okay, so you can see that two of them are planar and one of them is non-planar. So the non-planar one, this one is the non-planar one. Okay, now there is one condition for resonance which we discussed in this topic also. So resonance requires a planar carbocation. Planar carbocation. Resonance occurs only in a planar carbocation. Therefore, if resonance is occurring in planar carbocation, which implies that a planar carbocation, we are making a generalized statement again, a planar carbocation will of course be more stable than a non-planar carbocation. Why? Because we know that we know that resonance is a cause of stability. Wherever there is resonance, there is stability. So resonance is linked to stability. And if there is resonance, there is stability in the molecule. So if carbocations are planar, then they'll show resonance. And if they show resonance, then they show stability. So a planar carbocation showing resonance will be more stable than a non-planar carbocation. This is the part we have to remember, that a planar carbocation is more stable than a non-planar carbocation. Now here, if I mark them, these examples as first, second, and the third one, I can say that the third one is non-planar. So this is non-planar for us. A non-planar carbocation, whereas these two are planar. This is planar and this one is planar too. So can we say that 1 and 2 will be more stable than the third one? So first and second, this is the first deduction we are seeing from the above discussion, is that 1 and 2 will be more stable than the third one. We are deciding the order of stability, of course. So now what we are seeing here is that 1 and 2 is greater in stabilization than the third one, because the third one is non-planar, a non-planar carbocation. So what happens is, now we have to decide between 1 and 2 which one gets to have the crown of stability. So 1 and 2, in 1 and 2 we can see that the first one here has 3 electron donating groups, which we can see that this 1, 2, and 3, because there are actually CH3 attached here, if you know what we have been drawing. So there are actually CH3 attached over here, 3 CH3 attached over here. So what I can deduce from this is that there are 3 electron donating groups. But in the second one here, there is no electron donating groups attached to this. So the carbocation will not be stabilized, the positive charge will not be stabilized, and thus we can say that the first one becomes more stable than the second one, and of course both of them are more stable than the third one. So this is actually the order of stability that we have just got. First is greater than second, which is greater than third. So if I mark it here in the figure, it is that the first one is greatest, of course, has the greatest stability, and second is greater than the third one. So this is how we solve the question. We first see which one of them is non-planar, so we exclude it out of the conversation, because of course non-planarity will not lead to resonance, not lead to stability, so that is out of the question now. We are left with first and second, and we have already discussed that a 3-degree carbocation is more stable than a 2-degree carbocation, more stable than 1 degree, and more stable than a carbocation which has no electron donating groups. So since one has an electron donating group and it has 3 electron donating groups, so of course it becomes more stable than the second one, which in turn becomes more stable than the third one. So this was the answer of the question.